Welcome to Maths is Easy. Hello friends, yes, there is always a need of help in calculating or solving mathematics question on different levels. I am here for the same. Today in this video, I am going to solve chapter Quadrilaterals, exercise 12.3. Question number 1 to 6. So if you guys want to see the solutions of earlier chapters like rational numbers, exponents, square and square roots, cubes and cube roots, algebraic expressions, factorization of algebraic expressions, linear equations in one variable, earlier exercises of quadrilaterals, probability, playing with numbers, you can go by the playlist or you can go by the description box where the links are available. So not to waste further time, let's check it out how to solve exercise 12.3 question number 1 to 6 of chapter quadrilaterals. Publication house Goyal, class 8. So question number 1 says in a quadrilateral opposite sides are equal and one angle is 5 times the other adjacent angle. What is the figure called? So if we take a quadrilateral, suppose, and name it like A, B, C, D. So the conditions which are given to us is opposite sides are equal. This is equal to this and this is equal to this. And one angle is 5 times the other adjacent angle. Suppose if we take angle A as X, so adjacent angle B will definitely be 5x. So here it is asked what is the figure called. So if the opposite sides are equal, it should be a parallelogram only, because in parallelogram opposite sides are supposed to equal. And another condition, one adjacent angle is 5 times the other. So the sum of adjacent angles in a parallelogram is of 180 degree. So we can find out both the angles also is 180 degree. So here the figure definitely is parallelogram. So it was the first part of question number first, and in second part it is asked in the above quadrilateral, if all the sides are equal, what will it be called? So in the same quadrilateral, if all the sides are equal, so it will definitely be called as rhombus, because in rhombus all the sides are equal. So have a full glance of question number first. Now come to the question number 2. So question number 2 says, if one angle of a parallelogram is 105 degree, find the other 3 angles and the ratio between the 4 angles. Suppose this is our parallelogram and we will name it A, B, C and D. So what is it given? One angle. Suppose one angle, let's say angle A is 105 degree. It is given to us. So find the other 3 angles and the ratio between the 4 angles. So we all know that opposite angles of a parallelogram are equal. So if angle A is 105 degree, angle C will also be 105 degree, because opposite angles of a parallelogram are always equal. So angle C will be 105 degree for sure. Now, in a parallelogram, the sum of adjacent angles, angle A and angle B, should be 180 degree. So if angle A equal to 105 degree, so angle B would become 180 degree minus 105 degree, that is 75 degree. Why? What is the reason? Sum of adjacent angles of a parallelogram is 180 degree. So angle B will become what? 75 degree. So if angle B is 75 degree, the opposite angle, which is angle D, will also become 75 degree. If angle B is 75, angle D will also become 75. So why? Because opposite angles of a parallelogram are equal. So according to the question, if we had to find the measure of all the three angles. If one angle is given to us, so angle A was given to us as 105 degree. So angle B would become 75 degree. Angle C would become 105 degree. Angle D would become 75 degree. And if we have to find the ratios, angle A is to angle B is to angle C is to angle D. So we would write angle A as 105 degree is to 75 degree is to 105 degree is to 75 degree. So we will cancel it. It will go by 5. 21 is to 15 is to 21 is to 15, and it will go by 3 only. 7 is to 5 is to 7 is to 5. So here the solution of the question which is asked, the measure of all the angles and the ratios. So this is our answer. Hope all the questions are clear. If still any type of doubt is there, feel free to ask your queries by commenting into the comment box. Have a full glance of question number 2, exercise 12.3. Now come to the question number 3. So question number 3 says, in a quadrilateral ABQP, AB equal to PQ and AB parallel to PQ, show that ABQP is a parallelogram. So here we will make a diagram. It is like A, B, Q and P. So what is given to us? We have been given what? AB equal to PQ and AB parallel to PQ. Now we have to, and this is equal, AB equal to PQ and AB parallel to PQ. This is given to us. So here we will make, or we can say we will join the BP. For the sake of convenience, we will join the BP. So in our next step, as AB parallel to PQ, we can say angle ABP equal to angle QPB. Why? What is the reason? The reason is interior alternate angles. So we will make, or we can say we will write it as our first result, or we can say we will write it as 1. So in our next step, in triangle ABP and triangle QPB, AB equal to QP, which is given to us, AB equal to QP, it is given to us. Then angle ABP this is P. Then angle ABP is equal to angle QPB from 1. We can say from 1. And BP equal to, third thing is BP equal to PB, which is common. So we can say triangle ABP, we can say triangle ABP is congruent to triangle QPB by SAS congruence. So if both the triangles are congruent, so we can say AP equal to QB by what? By CPCT. CPCT means congruent part of congruent, corresponding part of congruent triangle. So we can say therefore ABQP is a parallelogram where AB equal to QP. AB equal to QP means opposite sides are equal. AP is equal to QB, which we have just proved, which is also opposite sides of parallelogram, and AB parallel to QP. So all these conditions make ABQP is a parallelogram. Hope the question number 3 is quite clear. Have a full glance of question number 3, how to solve it. Now come to the question number 4. If any type of doubt is there, feel free to ask by commenting into the comment box. Now let's check it out how to solve question number 4 of exercise 12.3, publication of Goyal Brothers, class 8 quadrilaterals. So question number 4 says, So question number 4 says of exercise 12.3 chapter Quadrilaterals, class 8, publication of Goyal brothers. In a parallelogram ABCD, E and F are the midpoints of BC and AD. So we can say that this E and this F are the midpoints of BC and AD. So what we have to show that AFCE is a parallelogram and second triangle ABE is congruent to triangle CDE. This triangle we have to show is congruent to this triangle. So how we will solve it? First of all, we will write in a parallelogram ABCD, AB equal to CD. Why? Because these are the opposite sides of a parallelogram, and AD equal to BC. Why? Because these are also the opposite sides of a parallelogram. Now, in triangle A, B, E and triangle C, D, F, we will take these both triangles, ABE and CDE. Now, AB equal to CD. Why? Opposite sides of parallelogram. In the same angle B equal to angle D. Why? Because these are the opposite angles of the parallelogram. So opposite angles of parallelogram are always equal. Opposite angles of a parallelogram. And BE equal to FD. Why B equal to FD? Because E and F are the midpoints which have been given to us. So through these we can therefore triangle ABE is congruent to triangle CBF by SAS congruency. How? By SAS congruency. So if these triangles are congruent, we can write AF equal to CE. Why? Because these are opposite sides of parallelogram ABCD. So we can write by congruency AE equal to CF by CPC, corresponding parts of congruent triangle. Therefore, we can write AFCE is a parallelogram. So what we have to prove? So here we had to prove AFC is a parallelogram, which we have proved here. And what we have to prove? We have to prove triangle ABE is congruent to triangle CDF, which we have proved here. So hope the question is quite clear. Nothing is there in the question. We have to just by SAS we have made the triangles congruent, and by the rule of parallelograms, opposite sides of parallelograms, we have proved opposite sides as equal. So AFC is a parallelogram and triangle ABE is congruent to triangle CDF. Hope the question is quite clear. Now come to the question number 5. So question number 5 says ABCD are the midpoints of side PQ, QRRS and SP of a parallelogram PQRS respectively, as A, SB, QC and QD have been joined to intersect at E and F. Show that EQFS is a parallel. What we have to show? We have to show EQFS, this figure, as a parallelogram. So how we will do it? First of all, we will write A and C are midpoints PQ and S are respectively. Therefore, AP equal to AQ, which is PQ divided by 2. This we will make it as first statement. Then SC equal to CR. This is SC equal to CR, which is half of CR, which is half of SR. This we will make it as second statement. And PQ equal to SR. This we will make it as third statement. Why? Because opposite sides of parallelogram. Now, from 1, 2, and 3, we can conclude that AP equal to AQ equal to SC equal to CR, and we will make it as our fourth statement. Now, in triangle APS and CRQ, AP equal to CR while using fourth statement. Now, angle P is equal to angle R. Angle P equal to angle R. Why? Opposite angles of parallelogram. And PS equal to RQ. Why? Opposite sides of parallelogram. Therefore, triangle APS is congruent to triangle CRQ by SAS. Now we can say as AS equal to CQY by CP. Now rest of the question I'm doing here. AS equal to CQ by CP. Now as AS equal to CQ and SC equal to AQ. Therefore, ASCQ is a parallelogram. ASCQ is a parallelogram. Now, if ASCQ is a parallelogram, we can write AS parallel to CQ and ES parallel to FQ. This we will make our fifth statement. Why? Opposite sides of parallelogram are parallel. So DSBQ is a parallelogram. So BQ parallel to SC. We can write this. So in our next step, we will write EQ parallel to SF, and this we will make our sixth statement. Why? Opposite sides of parallelogram are parallel. So from fifth and sixth, we can conclude that ESFQ is a parallelogram. Hence, so it was whole was the question. First, we have proved, we have make our statements 1, 2, 3, 4, and by using 4 we have proved AP equal to CR. Then we have make the triangles congruent. Then we have proved ASCQ is a parallelogram, and from make our fifth and sixth statement, and from fifth and sixth statement we have proved ESFQ is a parallelogram. So hope the whole question is clear. If still any type of doubt is there always feel free to ask your doubts by commenting into the comment box. Now come to the sixth question, which is the last question of this video. Question number 6. Have a full glance at question number 5 first. Now come to the question number 6. So question number 6 says, in a rectangle, PQRS, so this is, we can take it as our rectangle. So P, Q, R, and S is a rectangle. O is the midpoint. We will take O as our midpoint. O is the midpoint of PQ. Show that triangle POS is congruent to triangle QOR. So this will meet at O, and this will meet at R. So what we have to prove? We have to prove triangle POS, this triangle, and triangle QOR as common. So how we will prove it? In triangle POS and triangle OQR, PS equal to QR. Why PS equal to QR? Because opposite sides are equal of rectangle. PO equal to OQ. Why PO equal to OQ? Because midpoint, which is given to us, and angle OPS equal to angle OQR 90 degree, because all the angles of a rectangle are of 90 degree. Angles of rectangle are of 90 degree. So therefore we can say triangle POS is congruent to triangle OQR by SAS. So this is what we had to prove. So this was the question. Hope all the questions from question number 1 to question number 6 of exercise 12.3 quadrilaterals class 8 Goyal brothers are clear. If still any type of doubt is there, you can ask me by commenting into the comment box. So if you guys like my videos, or if it is somewhere helpful to you, subscribe to my channel, hit the like button, and share the videos as much as possible. In my next video, I'll be solving next 6 question or 5 question of the same exercise, that is exercise 12.3 quadrilaterals class 8 publication house Goyal. Thank you so much.